nothing too special to talk about today, I think. Um, yeah, I guess what I'm really hoping for today is it's been 2 days since we've had one of those problems about the CPU, about the building a machine and interpreting code. So today's the third day since that question, right? That was day 8, I believe. Yeah. So I'm really hoping for that today's the day that we're going to get to do another one of those questions, extend the code that we had on that day. Who knows? Maybe it won't be that. Maybe that was a one-off question this year, but I'm hopeful. Yeah, yesterday's question was interesting, right? Yesterday's question, it wasn't just a programming thing, right? You couldn't brute force it. You had to work out what the optimization was, what the underlying principle behind that question, behind what the task was. Um, and for me, that's the kind of challenge I really enjoy, because you really have to sit down and work it out. You can't just um, get a super fast computer to brute force your solution for you. So that was cool. Um, yeah, I'm gonna keep trying to explain things as well as I can. I think that, like, for me, this is really good practice. This is really good um, way to practice putting out my thoughts. I was talking to a friend last night, and I mentioned that I watched this channel called Cracking the Cryptic, and they do Sudokus. And well, they started off doing cryptic crosswords, but then they pivoted to Sudokus, and now they do mostly Sudokus and a cryptic crossword every now and then. But yeah, those two guys, Simon and Mark from that channel, they are brilliant at explaining things um, in a way that people can understand, right? And they're very thorough with their thought processes. Um, and yeah, the more I watch them, I guess the more I am inspired to work on my ability to explain my thought process as well. I think it's a really good skill to have, especially if you're an engineer. Uh, if you're working in a team, you want to be able to explain what your thoughts are, why you want to do something, and not just. I think the classic thing that a lot of, let's say, inexperienced workers might do, especially if you're really smart and you did really well at uni, right? You might be like, well, of course you do things this way because it's obvious, but that's not helpful. So to be able to put your thoughts down in succinct, concise ways that other people can follow and understand is a really good skill to have. So when you're nearing the 2-minute mark, just past the 2-minute mark, 2 minutes to go mark. So yeah, still looking forward to it. In other news, I think yesterday or the day before, SpaceX just had the test of their Starship rocket, and that was another amazing piece of engineering and video to watch. So if you haven't watched that, or if you don't know anything about SpaceX, that's again something super worth watching. Look it up. Starship, SpaceX, SN8 test. They're doing crazy, amazing things in terms of engineering and design, but with rockets. The other crazy thing is that rocket is like 236 feet. So it's like 23, 24 stories tall, right? And this is a thing that they're landing standing up, or trying to land standing up. And again, super cool stuff. We have 50 seconds to go. I'm super excited. Whatever this problem is going to be today, I'm looking forward to it. And so now we just have to sit through an awkward 30 seconds of silence because I have things to talk about. So let's just wait for those last 30 seconds and see what is going to go on. All right, Here we go. 5 seconds to go, and I am hoping for another CPU question. So, no. All right. Okay, no, this is another normal question. I will get my input first. That is a really big map. So that's my input. I don't need any of this stuff. Cool, let's read it. So my plane has finally landed. I've realized I'm so early that no one else has landed here yet. By modeling the process, people choose to abandon their seat in the waiting area. You're pretty sure you can predict the best place to sit. The seat layout fits nicely like this. L is an empty seat, hash is an occupied seat, and a dot is no seat. For example, the initial layout might look like this. Now you just need to model the people who will be arriving shortly. Fortunately, people who are entirely predictable and always follow a simple set of rules. All decisions are based on the number of occupied seats adjacent to a given seat. Occupied seat adjacent. One of the 8 positions. Okay, so it's not just orthogonally adjacent, it is adjacent in every direction. Following rules apply. If a seat is empty and this is like a what do you call it? Game of life kind of thing, right? It's like a yeah, it feels like it anyway. It's one of those things where the state of the thing changes based on its last step, and it just keeps updating itself. If a seat is empty, there are no yeah, it totally is. Right? If a seat is empty and there are no occupied seats adjacent to it, the seat becomes occupied, and there are no occupied seats adjacent to it. Cool. If a seat is occupied and 4 or more seats adjacent to it are also occupied, the seat becomes empty. Otherwise, the seat state does not change. Floors never change, seats don't move, nobody sits on the floor. So after one round, yep, because every seat doesn't have an occupied seat next to it, every seat becomes occupied. After a second round, the seats with 4 or more occupied adjacent seats become empty again, and so on. At this point, something interesting happens. The chaos stabilizes, and further application of the rules cause no seats to change state. Once people have stopped moving around, you count 37 occupied seats. Cool, so how many seats end up occupied in my input? That's pretty straightforward to do. So the first thing I'm going to do is put this into an array, because I think an array is easier to work with than strings. So const seat, let's call it a map, equals, we're going to map, this is confusing, so I'll call it seats. I'm going to take each line of the input and convert it to an array. So if I split the string on empty string, I will get an array, I think. And I'll print out seats now. Cool, so now I have an array of arrays. So we'll put a function and call it step. We'll call it last. Let's see. Yeah, we'll need to loop over every single, this is one of those like four, there are probably smarter ways to do this, but the easiest way, the most intuitive way to do it is to simply loop over every seat and check the 8 seats around it and count the 8 seats around it. So we're gonna have to loop over y first before x, because that's the way the array is laid out. Y is less than last dot length y plus plus. For let x equals 0, x less than last y dot length x plus plus, to make sure we don't go out of bounds. And so for each one, now we have 2 more loops. For let dy equals -1, dy less than or equal to 1, dy plus plus, and then we have dx as well. This is just the way that I'm used to writing this bit of code. And so we'll call it const y1 equals y plus dy, const x1 equals x plus dx. If x1, and then we need to check for out of bounds if x1 is less than 0 or x1 is greater than or equal to last y dot length, or y1 is less than 0 or y1 is greater than or equal to last dot length, then we continue. we also want to ignore the case. We don't want to check ourselves as well. So if dx is 0 and dy is 0, we also skip that case. Yeah. Then we continue. Otherwise, we count. So let count equals 0 if last y1 x1 is, what are we counting? We are counting if an occupied seat and 4 more adjacent seats are also occupied. So we're counting occupied seats equals occupied seat count plus plus. Now, if the seat is empty and there are no occupied seats next to it, yeah, we're counting occupied seats, right? Cool. So we've counted. So count is now equal to the number of occupied seats next to whichever seat we're checking at the moment. Now we want to check if the seat we're checking is an empty seat. I just realized my L is an empty seat because it looks like a seat. That's pretty cool. If the current seat is an empty seat, and let next equals, we'll do this. Let next, we'll just let next first. If it is an occupied seat and count equals 0, the seat becomes occupied. So I guess let next equals, next should start as being the previous one, right? As the current thing. Else if the current seat is occupied and there are 4 or more adjacent seats that are also occupied, the seat becomes empty. And count is greater than or equal to 4. Then it becomes an empty seat. Otherwise, it stays the same. Cool. Now we need const ret, we'll call it ret here. Const row equals that. So row dot push, we can push into the row, yeah. So here row dot push next, and also outside of here ret dot push row. We need to ret dot push row at this level. And then here we can return ret. Cool. I also want a way to print this out, right? So I'm just going to put this together as well. Debug. I'm going to call it map this time. Map dot map. How do you join maps in? How do you join an array in JavaScript? A dot join. Yeah. All right. Dot join with an empty string, and then we join that with a new line. Cool. So I should be able to debug seats here. See what we get. It's not gonna fit on my screen. That's a bit of a shame. I'm gonna have to like make my text a lot smaller. Sorry guys if this is hard to read. But it's the best I can do given what I have. So if I step this once, I should see everything occupied, right? Yes. Now if I step it again, yes. Okay, so it looks like it's working. So what I also want to do is I also want to keep track of whether or not we actually changed anything, because but it's really hard to compare this giant string. We can do that, but a simpler way is let has changes equals false, and then if we ever enter one of these branches, then we have had a change, right? So here we'll return ret and has changes like this. Cool. So if I debug, so I can't debug that anymore. Next, B, we'll just call it B for bool, equals step seats. Debug, I can debug that. What am I? No, I can't debug that. I can debug next and console.log v. Yep, has changes. So what we can do is we start with seats. We know seats is what we have. We're going to say while, no wait, this is a do loop. Do while, right? We're going to let start equals seats. Do let next has changes equals step seats. If we loop while has changes, yeah, I'm not sure how this thing works. I'm just going to do something like this. Map equals next, while has changes, debug, map. Does that work? Well, has changes, it doesn't know has changes, okay. So I don't know if destructuring works like this, eh? Can I destructure like this? Oh, next is already declared. I'll call it map then. Oh, whoops. I entered an infinite loop. And we don't need this anymore. Cool, and the question, so it looks like we've stopped. Cool, so the question was how many seats end up occupied? We can do that pretty easily too. Count occupied. This is another straightforward way to do this. We just say, we'll count it the old school way, right? Oh, should we? Yeah, let's count it the old school way. Sum equals 0, for let y equals 0. Now, okay, we'll do a fancy way, right? We'll go map.map. So this is each row, right? We're going to count the number of hashes in each row. So what's a way to do that? Can you filter strings in Node? A, B, C, 1, 2, 3 dot filter equals C, for example? No, you can't filter. But we can do okay, we'll count it the old school way. Count equals 0. We got one of these loops going on here, but it's not last anymore, right? This is map.length, and this is map_y.length. We're gonna say if map_y_x equals occupied, then count ++, and we return count. Console.log count occupied map. 2273 is my answer. Let's check it. Yes, 400th. That's pretty cool. All right, on to part 2. What is part 2? Part 2, as soon as people start to write, you realize your mistake. People don't care about those adjacent seats. They care about the first seat they can see in each of those 8 directions. Now, instead of considering just the 8 immediately adjacent seats, consider the first seat in each of those 8 directions. Oh, that's tricky. The leftmost seat below would only see one empty seat but cannot see any occupied seats. The empty seat below would see no occupied seats because in every direction, right, and the leftmost empty seat would only see one empty seat but cannot see any of the occupied ones, right? The first seat in each of those directions. Also, people seem more tolerant than expected. It now takes 5 or more occupied seats for an occupied seat to become empty rather than 4 or more in the previous rule. The other rules still apply. Empty seats that see no occupied seats become occupied. Okay, the other rules still apply. So given that change, things are now a little different. Again, we will reach equilibrium. So I think this most straightforward way to do this is to actually rewrite this function according to the new rules. It's probably easier than trying to change it. So I'm going to comment out this little loop in here for now. Right, so we're going to call this step 2. And this is the same thing, but this time we're going to have to follow these new rules. And we should be able to change it. So first thing, it says people are more tolerant, right? now takes 5 or more occupied seats. Okay, so the count is, if it's 5, so it's now 5. That's the first change. The other rules still apply. Empty seats that don't see, right, so the only thing that's changed is how many seats they see. Now, luckily for us, how many seats they see is right in this little block of code. So everything else technically should be able to stay the same, and it should work. We just need to update this block of code to do this new thing. So the way I'm thinking of doing this is we're just going to have to loop over each of those directions individually instead of doing like what I've done here, this dxdy thing, where I'm using dxdy in order to get the 8 spaces around it. I'm going to need to define a way to iterate over all the chairs in each direction. So a straightforward way to do that is like this. I would first define a collection of directions, and each one is going to have an offset, x, y offset, to show to tell me how to move in that direction, right? So we're going to go x, y. We're going to go dx, dy in that order. So for example, to go north, I'm going to start north and go around clockwise. So to go north, we want to change x by 0, but we want to change y by -1. It looks like we could still end up using that same loop. But I'll do it like this. So to go northeast, we want to go x is 1 and y is -1. To go east, we want to go x is 1 and y is 0. I'm going to put an extra space in here to line it up eventually. To go southeast, I need to go x is 1 and y is 1. To go south, x is 0 and y is 1. To go southwest, x is -1 and y is still 1. To go west, x is -1 and y is 0. And to go northwest, x is -1 and y is also -1. So yeah, I think we could still have done something with that loop from before, but this way is a bit easier for our brains to understand because we can see each one of these directions. Maybe I'll put these in just to keep things a bit easier to follow. Cool. And so what we want to do is take each of these directions from our current position, keep moving in this direction until we until we get out of bounds. Right, until we get out of bounds. So we're gonna say while something, not sure what that is yet, const y1 equals y plus dir1, const x1 equals x plus dir0. Okay, maybe we can do this. Yeah, I'll just write it out like this so it's a bit easier to understand, easier to see. So we'll destructure it like that, and then we can have the same code as we had before. Right? If we are out of bounds, so we don't have this check anymore, but if we are out of bounds, then we want to break out of this loop, right? If, okay, so yeah, if I'm gonna make this an infinite loop. If if last, is it still called last? Yes. If last y1 x1 is a floor, because we care about the first seat we find, right? The first seat in those areas. So if it's a floor, we continue. Do I still have the count value variable? Yes, I still have the count variable, right? Then we continue. We loop on to the next one. If we break here, that means we've reached the end without finding a chair. Yeah. Otherwise, if we find an empty chair, we break. If we find a occupied chair, we increase the count, and then we break. Cool. In fact, that should pretty much be it. This time I'm going to check with this input because I kind of don't trust my programming for something a bit more complex like this. So example input. Is this. And we're going to step example. I can't do that, eh? I need to go debug in. Okay, so I've broken it, I believe. I have entered an infinite loop somewhere. Ah, I'm always checking just the same value, right? I need to check the one, I need to update this. So let, okay, let y1 equals y, let x1 equals x. And then I need to update it, right? y1, yx plus equals dy and dx. Because we want to keep checking, we want to take into account the last one we've checked. Okay, oh, whoops, wrong button. Let's just check if that's the same. That looks the same, which is good. We're going to check that, step that again. In one, I'm going to ignore that. Oh, we can't do that. Maybe we can do this. Okay. We'll do it like this. I'm not sure how to do this. Now, is that the same as the next one? We need to print a new line in between so we can separate the things. Okay, does that look the same? That looks 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so that looks the same. But let me just check one more step, just to make sure this looks good. One more step. Okay, so we have 5 in the first row, yes. 6 in the second row, yes. 3 in the third row, yes. I mean, that looks pretty good to me. Okay, so since that looks good to me, I'm just gonna run it on the input and see what happens. I'll take the same code I had before. Let's see, let map equals seats has changes as false, map has changes as step 2 map this time. While this changes, we'll print out the map and we'll print count occupied. 2064. Let's go. Yes, we got it, 500. Cool. So that was a really fun challenge again. Again, it's relatively straightforward. If you've done this sort of programming before, you would recognize the patterns that I used. I remember doing something like this with Minesweeper. If you've never programmed Minesweeper before, you will end up with code that looks very similar to this, because with Minesweeper, that's what you're doing, right? You're checking the 8 cells around each cell. And so you will have, so if you write Minesweeper in a relatively straightforward way, you will end up with this kind of, this sort of pattern of loop where you have like this 4-step kind of for loop. For example, in order to populate the values of each cell in Minesweeper, this is a relatively straightforward way to do that. And there might be a more efficient way to do it. But yeah, like I said, this is the straightforward, kind of intuitive, I don't want to use the word naive, but yeah, that's why I like the word straightforward way to do that. And yeah, enjoyed the challenge. Thank you for making it. And that's all it's going to be for today. I don't really have anything else to talk about this. Clearly, I could have, like this while loop. There's probably a better way to write it, but off the top of my head, this was the most straightforward way the most intuitive way, let's say, to do it. So I did something like that. And maybe if you sat down and thought about it for a while, you could come up with a nicer bit of code. But all in all, that's it. Thank you for joining me, and I will see you again tomorrow. All in all, that's it. Thank you for joining me, and I will see you again tomorrow.